Hello everyone and welcome back to another exciting session from PostNetwork Academy. I am Bindeshwar and this is a part of our data science and AI lecture series. In our last video, we discussed how to calculate the moments of a data set, both about the mean and about an arbitrary point. These calculations are foundational for today's topic, as we will use those concepts to determine skewness and kurtosis using Pearson's beta and gamma coefficient. If you haven't watched the previous lecture yet, I highly recommend checking it out. It will give you the background needed to follow along today. And for more resources and videos, you can follow Post Network Academy website, YouTube channel, Facebook page, and LinkedIn page. Now, Carl Pearson defined the following coefficient based on the first four central moments. So, the first coefficient beta is defined as mu3 square upon mu2 cube, where mu3 is third moment about mean and mu2 is second moment about mean. It is a measure of skewness. For a symmetrical distribution, beta should be 0. But beta does not give any direction about whether it is a negative skewness or positive. So to resolve this problem, we will just take under root beta and that will become mu3 upon mu sigma q and that will be used for calculation of skewness. Now let us understand beta 2. Beta 2 is defined as mu 4 upon mu 2 square. Mu 4 is fourth moment about mean and mu 2 is second moment about mean. Now the coefficient of kurtosis gamma is defined by gamma 2 is equal to beta 2 minus 3, and these coefficients provide insight into the distribution shape. Now let us take an example, frequency distribution of marks, and you can see that another table, frequency distribution table with derived columns. So we will require FD, that means F is frequency and D is, you can say that, deviation, that means observations. You can say that 20G subtracted from observation and it is divided by 5. So you will get FD square, FDQ, FD FD raise 4, and you can see the summation of all FD minus 6, summation of all FD square 178, summation of all FDQ minus 42, and summation of all FD raise 4 874, and these values we will use for calculating moments about an arbitrary point, and in this case we have 20, and we have also divided that, you can say that, deviation from 5. So let us see that here. So mu prime 1, that is you can say that first moment about an arbitrary point, and that is 0.30, that is in negative. Mu 2, you can say that fd square upon n into h square, that would be equal to 44.50. Third moment minus 52.50, and fourth moment 5462.50. And I have already discussed in the previous videos, the relationship between central moments and moment about arbitrary points. So mu2 is equal to mu2 prime minus mu1 prime whole square. The same way third one, mu3 is equal to mu3 prime minus 3 mu2 prime mu1 prime plus 2 mu1 prime cube, and that would be minus 12.50. Again 4 there is. Fourth moment, mu4 prime 4 mu3 prime mu1 prime 6 mu2 prime mu1 prime whole square minus 3 mu1 prime raise 4, and that is 5423.5057. Now use these values and we will calculate Pearson's beta 1, gamma 1, beta 2 and gamma 2. So let us see that. So beta 1 is mu q square upon mu 2q. Now the standardized skewness coefficient. So gamma 1 should be used, and that is, you can say that mu 3 upon sigma q, and that is equal to minus 0.0422, and that is negative. So that means it is negative skewness or left skewness. Almost it is 0, so it is symmetrical but little bit negative skewness in data distribution. The kurtosis coefficient beta 2, that is mu 4 upon mu 2 square, that is equal to 2.7499, and you can understand if beta 2 is equal to 3, so there is no kurtosis, but is less than 3. If it is 3, it is like normal curve. I will discuss in upcoming videos. And see that the standardized kurtosis coefficient is minus 0.2501. So it is negative, so it means it is platykurtic. So in this video, you have understood gamma coefficient, beta coefficient, and how to calculate skewness and kurtosis. Hope you have understood. If you have liked the video, so hit the bell icon. If you are watching on YouTube, if you are watching on Facebook, so like the page, like the post, and also follow the page. If you are on LinkedIn, so like the video and follow PostNetwork Academy. So see you in the next video.